CUbit, or the CUbit Quantum Initiative, is an organization within the University of Colorado Boulder. It was established by CU Boulder, the NIST, or National Institute of Standards and Technology Quantum Physics Division, as a core component of JILA, and the Front Range Quantum Technology companies with goals to advance quantum research, educate and develop the next quantum workforce, and help contribute to the biggest quantum engineering challenges facing the field today. The CUbit Quantum Initiative is not just a scientific endeavor. It represents a modern vision of how a collaborative hub where academia, industry, and government converge. In today's episode, we'll explore how CUbit is shaping the world of quantum technology and ultimately positioning Colorado as a national and international leader in quantum science and research. To do this, I'll be interviewing some of the key figures within both CU Boulder and CUbit, including CU Boulder Chancellor Justin Schwartz, CU Vice Chancellor for Research and Innovation and Dean of the Institutes and Slade Professor of Engineering Massimo Ruzzene, CUbit Executive Director Scott Sternberg, JILA Fellow and CU Boulder Physics Professor and CUbit Faculty Director for Education and Workforce Development Heather Lewandowski, and CU Boulder Physics and Electrical Engineering Professor Scott Diddams. They'll each be sharing how CUbit has made an impact both within and beyond the CU Boulder landscape. So join us as we unpack the mission, vision, and work of the CUbit Quantum Initiative. You're listening to Humans of JILA, a JILA podcast focusing on the human narrative of the institution's researchers. I'm your host and science communicator, Kenna Hughes-Castleberry. Every month, I tell the story of a researcher or group within JILA, showcasing the human sides behind the science. If you enjoyed today's episode, please like it on our YouTube channel or follow us on Spotify, and be sure to share it with your friends and family. This episode focuses on the CUbit Quantum Initiative and includes interviews with various stakeholders across CU Boulder and JILA. So whether you're a physics enthusiast, a current JILA member, part of JILA's vast alumni network, or considering JILA or CU Boulder as the next step in your career, stay tuned as we dive into the ins and outs of the CUbit Quantum Initiative. Let's begin our story. While a university can seem like a very complex machine comprised of different departments and institutes, the picture becomes much more complicated when you add in organizations like CUbit. These organizations are essential as they help universities extend their reach to new partners and audiences to drive innovation. For CUbit, its history is fairly straightforward, and it begins, no surprise, on Capitol Hill.
Hello, my name is Scott Sternberg. I serve as the Executive Director of the CUbit Quantum Initiative here on the CU Boulder campus. So about 5 years ago, there was an activity at the federal level. It was called the National Quantum Initiative, and that was intended to provide authorization legislation for the quantum industry to, let's say, coordinate federally funded research for quantum science, and also spun up this idea of the Quantum Economic Development Consortium, which is a industry association, for lack of a better term, that convenes the industry players around the quantum industry. And so in many ways, that really congealed the policy and the focus and the coordination of quantum science and the quantum industry here in the United States. At about that same time, here on the CU Boulder campus, we convened a group to look at how we would best, let's say, grow our quantum presence here on the campus. And so that was the birth of the CUbit Quantum Initiative, spelled CUbit and pronounced CUbit. And so in many ways, it was to mimic this federal initiative to ensure that you're looking at all of the dimensions of the quantum industry. So for us, 60 plus years of JILA history and quantum discovery certainly has put us on the map internationally as a leading institute for quantum science. But we also have a growing engineering initiative around quantum science. A lot of companies are being spawned out of the university. And of course, we want to be thought leaders, both to influence legislation, but then also to sort of drive generally the direction of the quantum industry. And so the CUbit Initiative was created to, let's say, look horizontally through all of those functions here on the campus, such that we can maximize the benefits of an interdisciplinary approach towards this quantum information science and technology programs and initiatives. And so in many ways, it was a stealing from the feds and looking at a way to best maximize our efforts here in quantum science.
While Sternberg hasn't been the executive director of CUbit for very long, he has quickly developed successful partnerships with key leaders on campus, such as
Justin Schwartz, Chancellor. So the world of quantum is in the process of transitioning from basic physics into material science and engineering and devices. And one of the true strengths of this region is the fact that we've got major Research One universities that have core strength in the science and in the engineering. We have multiple national labs with expertise and can also do some of the applications pull as opposed to simply science push. And so we have all the ingredients in terms of the critical expertise. So when we talk about technology development, we talk about what we call TRLs, technology readiness levels. And so TRL 1 means brand new sort of physics idea breakthrough. TRL 9 means essentially going to market, right? And so CUbit fits a number of those TRL levels, but you can't get to TRL 4 if you don't have 1, 2, 3, right? And so 4 Nobel Prizes at CU certainly sets a good platform to build on. And we've really done a great job of building on that over the years. So it's, we point to the 4 Nobel Prizes as sort of the underpinning because it's something that, anyone who hears that gets it. But really the diversity of scientific expertise at CU and CUbit really builds on that origin story and fills out so many of the different areas of technical need to actually see the science progress to technology through those TRL levels. So it really occupies a key space in that TRL space.
Chancellor Schwartz is just one of the many CU leaders helping to support CUbit. Another is Massimo Ruzzene, CU's Vice Chancellor for Rio, Dean of the Institutes, and Slade Professor of Engineering. In my interview with Ruzzene, he highlighted the goals he hopes Rio and CU can support CUbit in achieving.
So I would say CUbit should continue to be what it is. That is a entity that connects and expands the footprint of quantum on campus. And that, again, like I said, the original intent was to pursue large projects, which it has been successful to a larger extent. Doing QSense is one of them. It's probably the best example of that kind of a success. I would imagine that CUbit, and I would hope that CUbit continues to do that. There are opportunities at the horizon that we should really be pursuing, that we're prime candidates to be successful at. But I think CUbit has expanded its role, as I mentioned, and the goal of quantum, the way I see them, the quantum effort at Boulder are essentially can be formulated in 3 points. The first one is to really continue to foster our strength in the academic space and in the fundamental science space. So we really need to nurture that tradition, that success, our standing, be able to recruit the best faculty and the best students, and be a center of gravity of quantum science. That's goal number 1. The goal number 2 is to help and propel quantum as an engine of economic development for Boulder area and the state, the Front Range. And the third one is to establish our leadership in quantum education and quantum workforce. So with these 3 goals, all of these 3 goals can be facilitated and coordinated through CUbit. They don't have to go through CUbit, but CUbit can help pursue all of those 3 goals. And CUbit on its own is not just an empty container. It has people and it has reach into the faculty and the researchers that work in this area. So I would hope that CUbit is sort of a magnet for faculty who want to pursue these goals or help us pursue these goals and help them amplify their impact in these 3 areas.
Speaking of the goals CUbit has, Sternberg summarized the many different pillars CUbit is focused on and currently developing.
Falls into 5 different categories here. And the first one is just fundamental quantum discovery. I mean, this is where, JILA has performed over the last 60 years, continuing to drive our research and development programs to maintain our leadership in the fundamental discovery aspect of quantum. So that's really core to what we do, and that's, obviously a very important pillar of what we're doing to go forward. But as quantum science is moving out of the laboratory and into products, it really is becoming an engineering effort. And so our investments in what we call the Quantum Engineering Initiative is really focused on developing curriculum and research staff and faculty to develop products or engineering solutions that take advantage of quantum principles. So it's really the complement to the fundamental discovery and really what is the next stage in the quantum market development. Of course, here at the university, we have a very sharp focus on education and workforce development. And so a number of programs that we've put in place address things like experiential learning, introduction to basic quantum principles, developing quantum engineering, and then really engaging with the quantum industry, which is so rich here in Boulder. And so maintaining our presence to develop a pipeline of students that are ultimately going to work and potentially lead in the quantum industry is something that's very important to us. And not only just generating students, but also studying how we're teaching quantum in the education space is a research effort that we have ongoing, which we will expand. The fourth dimension is really around generating products and companies in the quantum science. And so this is intellectual property that is discovered here at the campus, rolled out through our venture partners group and out into the marketplace, either through licensing products that we generate or licensing and creating companies at the other end. And that's really where quantum will start to see an economic uplift in the general marketplace. The last one is the really exciting one, and that is taking what we've learned and what we've discovered at the fundamental levels of quantum science and applying it to the multiple disciplines where we think ultimately we will be able to generate a quantum advantage. This is in areas like biosciences, like in aerospace, even in the financial sectors. And so there's some really exciting applications that we're looking at. And here on a university campus where we have the breadth and depth of all of those disciplines, looking to interdisciplinary seed all of these quantum activities across all of the different areas of research is really the exciting future for CU Boulder.
One of the goals Sternberg highlighted was the need for workforce development for the growing quantum industry. To learn more about this, I sat down with JILA Fellow and CU Boulder Physics Professor and CUbit Faculty Director for Education and Workforce Development, Heather Lewandowski.
Generally, this idea of quantum research and quantum technologies is a nascent technology where it's really sort of starting to develop now. And there's great promise in the future for an ever-expanding sort of number of jobs and careers in this area. So it's really important that we start to invest in preparing our students to better enter this industry now so that they have all the opportunities to enter this.
Another key aspect CUbit is looking toward is overcoming key challenges in quantum research, including engineering. While the CUbit Quantum Initiative isn't itself focused on quantum engineering issues, its leaders hope to support the growth of a new organization, the Quantum Engineering Initiative, or QEI, to be able to tackle these issues. To learn more about the current quantum engineering challenges and QEI, I sat down with CU Boulder Physics and Electrical Engineering Professor Scott Diddams.
My name's Scott Diddams. I'm a professor in electrical engineering and also in physics here at CU. I'm a senior investigator in the NSF QSense collaboration and also the faculty director of what we call the Quantum Engineering Initiative.
Can you tell us a bit about why quantum research and engineering are important?
Yeah, that's a great question. I think quantum engineering and quantum research in general is important because it aims to solve problems and answer questions that we don't presently know the answer to. So these are questions, research topics, engineering topics that are at the very edge of our knowledge. And those are important to solve because they can have really important and big impact. And I think that is why, in general, this field of quantum science and engineering is so hot right now, is people recognize there's really hard, challenging problems that if we're able to solve them, we can do things that we could never have imagined doing before. And some of the examples of those things would be new types of computing or communication devices, fully secure communications, where communication channels can't be hacked, computing to solve problems that were previously thought to be unsolvable, very challenging simulations or cryptography problems. And then being able to measure things that we didn't think we could measure before. For example, there's an experiment that has been going on for like 30 years now called LIGO, the Laser Interferometric Gravity Wave Observatory. And just in the past few years, LIGO has taken on a quantum-enhanced nature, and topics like we study here at the University of Colorado have found their way into LIGO to enable it to measure to much greater distances in the universe. And those are distances, or that's a measurement capability that you just couldn't do without quantum science and quantum engineering.
Great, thank you. Speaking from your engineering perspective, what are some of the current engineering challenges that are being faced in this field?
Yeah. I think the biggest challenges and hard things to work on right now are to overcome complexity and fragility of quantum systems. If you look at the new types of measurement tools, like the most advanced clocks that people are building here at JILA and Junyi's lab, you walk into that lab and you look at it and you're like, wow, I've never seen anything like that. That's an amazingly complex system, even to someone who knows nothing about it. It's rather large. There's lots of wires and laser beams and mechanical components all across a table. So it's complex. It's also fragile, meaning that the most advanced types of quantum systems, the entanglement of atoms, the building of, if we want to call them, super atoms by combining individual atoms, that can be disturbed by a lot of things, by environmental fluctuations, by processes we call decoherence. And so when we look at this from an engineering point of view, there's, not just the questions or the challenges of, well, how could we take a very complex experiment and engineer it into a way that maybe if it was really going to be impactful, that it could come out of a research lab and go into a company, into, a measurement device or into a computing type device, somewhere in the real world, we might say. So there's that challenge of just understanding, like, how could you really put all the pieces together in a way that there would be an on-off switch and it could just run. And then related to the fragility, I think there's maybe that's a two-part problem. Is it some of that is just better control, engineering control of the system, but other aspects of it might be designing the system from its core constituents in a way that makes it more robust to external perturbations. So anyway, I would say those are probably two of the biggest engineering challenges.
Great. So could you tell us a little bit about what QEI is, how it's being developed, and then how CUbit, the organization CUbit, is impacting QEI?
Yeah. Well, maybe we start with CUbit. CUbit is the umbrella organization on the CU campus that is kind of coordinating and supporting all of quantum science, engineering, research, and then also outreach to the community around us. So QEI is a new organization that falls under this umbrella of CUbit. And similar to JILA, it seeks to bring together CU and NIST scientists to work on and solve some of these hard problems with more of an engineering focus. So maybe a simple way to picture it is we would like to recreate some of the success at JILA with more of an engineering focus. JILA has been here for 60 plus years, tremendous scientific output, tremendous impact, not only on the campus, but our country. And we see an opportunity now that JILA has laid such an amazing groundwork of scientific knowledge, particularly in quantum sciences, that we need to begin addressing the engineering aspects of those. So we would like to make a new home together where NIST people and university people, faculty and primarily in the College of Engineering, could join together to work on these problems. And maybe from a global picture, what we're going for is a bit of a triangle where we would have NIST at one point, we have JILA at another point, and there's a connection already that exists between NIST and JILA. And we want to make this new branch to the College of Engineering where we'd have a new, ultimately, it would ideally be an institute like JILA,
But we don't want it to be separate from JILA. We want, just like a triangle, to have a line connecting across campus, this translation of the basic science, the fundamental knowledge into engineered systems. And we think that's a really good recipe, not only building on the success of JILA, but to further the impact of our research and our science in our community and in our world.
I then decided to ask each of my interviewees the same or a very similar question. Why should universities and institutes have organizations like CUbit? I'll let Chancellor Schwartz share his thoughts.
So I think one of our missions is not just discovery in the research space, but actually seeing discovery go into impact, right? So, and this is something that over time universities have done more and more of and less of, depending on the era. But I think it's really critical that that the work that we do does translate to the impact on society that we envision, that we don't take a mindset of, we have this discovery, we've published it, now someone else can go figure out what to do with it, right? That we actually connect across those different material levels in a way that allows society to be impacted by the scientific breakthroughs, that gives opportunities for students at every stage of that process, right? So you'll have physics students, you'll have engineering students. Down the road, we're going to have marketing students, right? And talking about, science ed of what is quantum, why does quantum matter to me as a citizen of Colorado? So seeing that, there's impact in so many different ways beyond just the impact of the physics discovery, I think is really critical to what we do, and also critical to helping the more general public understand really the value that higher ed brings to the community.
I then decided to ask Professor Lewandowski her reasons for why CUbit is needed at a university level.
CUbit is really important because there are a lot of individual components happening across campus that we really want to connect and leverage to be greater than the whole. And so there are various programs in different departments, in the Research and Innovation Office, and CUbit allows us to really bring these folks together to tackle this large problem.
For his part, Director Sternberg answered my question in a very similar manner to Lewandowski.
I think the best answer to that question is to ensure that we're playing the whole game. And so what I mean by that is if you're a faculty member, your focus is in a very specific area, education or perhaps your research programs. But pulling back a little bit and looking at all of the research that we're doing across quantum in all of the different discipline areas and looking for opportunities, both strategic funding opportunities, but also strategic investments that the university might make to ensure that we're really growing our quantum reputation and presence here on the CU Boulder campus. And so this idea of looking horizontally across the university, looking in each of the departments, looking across each of the colleges, looking at the organizations like our Research and Innovation Office, our venture partners groups, all of that takes a lot of attention. And so a dedicated group that looks at that dimension is designed to really ensure that we're doing the right thing for the campus and for the future of the quantum industry.
But perhaps my favorite answer came from Professor Diddams, who put it all together in a very eloquent manner.
Yeah, that's a good question, too. I think we want organizations like CUbit, particularly on the university campus, because it provides a compelling vision for the future. A primary role of a university one of the primary roles is to develop and new knowledge, to discover things that people didn't know about before. And that associated with that are really hard challenges to overcome. And so at a university, a place like University of Colorado, I think having CUbit that is setting forth a vision on what quantum science, quantum engineering would be on our campus, what problems we would attack, how it would impact the world. I think that's it's really important to set that kind of tone, that compelling vision. It drives forward the research, it unifies people, and I think it importantly attracts the best minds and the best students when people can see, there's something happening at CU Boulder that is really tackling very hard and challenging problems. I would like to be a part of that. Sometimes those problems at the very edge. They're the most frightening ones. We don't always know the answer. It's a bit like taking a step out into the unknown to try and figure out how to solve them. But they're the most fun and exciting ones to work on. So I think it's really important to have an organization like CUbit that's providing the coordination, the vision, the environment where faculty and students, partners like NIST, and the larger community around us can really work on those problems. I like if I can throw in there a quote. I like a quote that I think fits well in the university setting from F. Scott Fitzgerald, which I think was from a short story called "To Crack Up," and it goes something like this, which I think fits well in the university setting. That like intelligent people should be able to hold two opposing ideas in their mind at the same time, and still retain the ability to function. For example, one should be able to see that things are hopeless, yet be determined to make them otherwise. And okay, things aren't hopeless in our research, but they're really hard. And sometimes when we look at a problem, we say, I have no idea how I'm going to solve that. But it's through a community and through colleagues, friends, students here on the campus, it kind of gives us that support where we say, hey, I have an idea. I think I could solve that problem, and we want to try and make it otherwise. So anyway, that's a bit of an inspiration that I hold whenever I work on problems. And in the community here, it's a great community to work in to solve really hard problems, particularly in this area of quantum science and engineering.
Thank you for listening to Humans of JILA, a JILA podcast. Be sure to subscribe to JILA's YouTube channel for more information and to keep listening to these episodes. This episode featured interviews with CU Boulder Chancellor Justin Schwartz, CU's Vice Chancellor for Research and Innovation, or RIO, and the Dean of the Institutes and Slade Professor of Engineering Massimo Ruzzene, CUbit Executive Director Scott Sternberg, JILA Fellow and CU Boulder Physics Professor and the Faculty Director of CUbit Education and Workforce Development Heather Lewandowski, and CU Boulder Physics and Electrical Engineering Professor Scott Diddams. If you wish to be appraised of all the quantum activities on the CU Boulder campus, please subscribe to our CUbit monthly newsletter found at www.colorado.edu/initiative/CUbit/news. Production design, sound design, and research by Kenna Hughes Castleberry, with assistance from JILA's Science Communication Office and the CUbit Quantum Initiative. Sounds and music by Pixabay and Kevin MacLeod. JILA is a joint institute between NIST and the University of Colorado Boulder. JILA hosts this podcast. Any use of this podcast without JILA's permission or credit is prohibited.